At 0710 local time, a Tomahawk missile erupts from the deck of the USS Spruance. The launch cell bursts open, and a column of fire and smoke punches upward as the missile rockets into the air. For a brief moment, the missile climbs sharply, pushed by its powerful solid booster. Then, just seconds after launch, the booster burns out and drops away, falling toward the dark water below. A small turbofan engine, roughly the size of a coffee table, spins to life with a high mechanical whine. The engine stabilizes the missile's flight, and the Tomahawk smoothly tilts forward, lowering its altitude until it is flying only about 50 feet above the waterline. At that height, it skims across the sea, its radar altimeter constantly measuring the distance to the waves to keep the missile low and hidden from radar. The next launch cell on the destroyer fires almost immediately after the first. Another missile blasts upward, repeating the same routine. Then another cell opens. Then another. One after another, the missiles leave the ship in a carefully timed sequence, each launch filling the air with thunder and flame. Sailors on the deck barely move as the system continues its automated firing cycle. Within 90 seconds, 8 Tomahawk cruise missiles have already been launched from the destroyer and are racing away across the water. Roughly 300 meters to the northwest, 2 other destroyers are conducting the exact same drill. Their launch systems ignite one after another in rapid succession, sending more missiles streaking into the sky before they level off and drop to low altitude. When the launches finish, a total of 25 Tomahawk cruise missiles are flying just above the surface of the Persian Gulf. Their routes have already been carefully programmed. Each missile follows a different path, weaving through gaps between Iranian coastal radar stations. The routes were chosen specifically to avoid areas where Iranian surveillance systems are strongest. The missiles skim over the waves like mechanical predators, using radar altimeters and terrain-following systems to remain nearly invisible. Their estimated flight time to the Iranian Revolutionary Guard naval bases along Iran's southern coastline is approximately 40 minutes. While those missiles are still far out over the water, another part of the operation is already unfolding inside Iranian airspace. A group of small drones suddenly appears on the radar scope of an Iranian air defense operator stationed at a Bavar 373 surface-to-air missile battery. The radar screen shows a cluster of slow-moving contacts coming inland from the coast. There are about a dozen of them. They are flying slowly, barely reaching speeds of 110 knots. The operator studies the screen for only a moment before deciding to engage. He presses the command to fire. A large interceptor missile launches from its rail with a burst of flame and smoke. The missile accelerates rapidly, guided by radar tracking toward one of the drones. The interceptor closes the distance quickly, flying at more than 3 times the speed of sound. The drone it is chasing is small, roughly the size of a riding lawnmower. Within seconds, the interceptor reaches it and detonates. The drone disappears in a small explosion of debris. The drones themselves are relatively cheap. They are manufactured by a company called Spectral Works in Mesa, Arizona. Engineers there developed them after studying captured Iranian Shahed 136 drones. Using the same general concept, they built simplified versions designed specifically to draw enemy fire. Each drone costs roughly $35,000 to produce. Compared to the interceptor missiles used against them, they are extremely inexpensive. Every time the Iranian battery launches an interceptor to destroy one of these drones, it reduces the number of missiles remaining in its magazine. When the 25 Tomahawk cruise missiles arrive later, the battery will have fewer interceptors available to defend against them. There is another consequence as well. Each time the Bavar 373 radar locks onto a target and fires, it broadcasts its position through the electromagnetic spectrum. Passive sensors carried by aircraft flying nearby are quietly listening for those signals. High above western Iraq, several stealth aircraft are already collecting that information. F-35 fighter jets cross the border without transmitting any radar signals of their own. Their electronic warfare systems silently record every radar emission coming from Iranian air defense networks. Each radar pulse reveals the exact location of another defense system. Behind those stealth aircraft, 12 Israeli F-15I Ram fighter jets have been climbing eastward through Iraqi airspace for nearly 90 minutes. The Ram aircraft remain hidden behind the electronic cover provided by the F-35I Adirs fighters leading the formation. The stealth aircraft operate in complete radio silence while constantly scanning the environment. Their sensors quietly map the entire radar network along the Iranian border. Each F-15I carries a single large missile mounted beneath its fuselage centerline. The weapon is called Rampage, a heavy standoff missile designed to strike distant targets at very high speed. As the formation approaches western Iraq, the pilots receive updated target coordinates. An Israeli Oran intelligence aircraft is circling high above Jordan, gathering surveillance data and transmitting refined targeting information through the Link 16 network. The coordinates for each strike have already been updated 3 separate times to ensure maximum accuracy. At 0805 local time, the formation finally reaches the designated launch altitude. The pilots stabilize their aircraft while weapons officers review the final targeting solutions. Inside the lead aircraft, the weapons officer studies the data one final time and confirms that everything matches the latest intelligence updates. The pilot grips the control stick and presses the release trigger. A heavy 2,500-pound missile suddenly drops away from the aircraft. As the weight disappears, the nose of the F-15I lifts slightly from the sudden shift in balance. A fraction of a second later, the Rampage missile ignites its solid rocket motor. Flames burst from the rear of the weapon as it accelerates forward, quickly breaking the sound barrier. The missile climbs upward on a steep arc, beginning a ballistic trajectory aimed directly toward Tehran. Within seconds, the remaining 11 F-15I aircraft release their weapons as well. One after another, the missiles drop, ignite, and accelerate eastward. 12 Rampage missiles streak across the sky at supersonic speed, climbing high above the region before beginning their long descent toward their assigned targets. Meanwhile, the empty rocket boosters separate and fall harmlessly into rural farmland scattered across eastern Iraq. At 0810, the standoff missiles reach their targets. Because they travel so fast, the warning time for Iranian defenders is almost non-existent. The weapons slam into the capital with tremendous force. Several of the warheads strike buildings inside the compound where the office of the Supreme Leader is located on Pasteur Street. The explosions tear through the structures, reducing several buildings to shattered concrete and debris within seconds. Almost immediately afterward, another wave of aircraft crosses the Iranian border. The stealthy F-35 Adirs fighters carry GPS-guided bombs known as JDAMs, as well as smaller precision weapons called GBU-39 small-diameter bombs. Inside the cockpit of one of the F-35s, the pilot does not need to switch between multiple displays or sensors. The aircraft's computers combine information from radar, infrared sensors, satellite data, and the Link 16 network into a single, clear tactical picture. As the pilot approaches Tehran at 25,000 feet, he rolls the aircraft onto its back and begins a controlled dive toward the Ministry of Defense complex. The targeting system locks onto the exact building coordinates. When the release point arrives, the pilot drops a GBU-39 small-diameter bomb. The weapon unfolds its small, diamond-shaped wings and begins gliding toward the city. Although it was released many miles away, the glide bomb is capable of traveling more than 40 miles before reaching its target. The bomb descends steadily toward the ministry complex, guided entirely by GPS coordinates. Moments later, it strikes the roof of the building. The hardened casing punches through several layers of concrete before reaching the third floor. A delayed fuse triggers the explosion inside the structure rather than on impact. The detonation rips through offices and corridors deep inside the building. Across Tehran, the same pattern unfolds again and again. Other bombs strike the Ministry of Intelligence. Additional explosions occur at the headquarters of the Atomic Energy Organization. At the Parchin military complex, more precision weapons hit storage buildings and research facilities. 700 meters south of Tehran, the next wave finally arrives. The Tomahawk cruise missiles that launched earlier from the destroyers now reach the Iranian coastline. Flying extremely low over the water, they cross the shore and head directly toward military installations along the southern coast. The first missile reaches Kalaye IRGC naval base at 0812 local time. The warhead slams directly into the command building. The structure collapses inward as the explosion tears through the interior. Nearby fuel storage tanks ignite immediately, sending a tall column of black smoke rising straight into the sky. Not long after, another aircraft approaches from the north. The shelter has a curved, half-moon-shaped roof, designed to protect several Paycon-class fast attack boats stored inside. The officer confirms the GPS targeting lock and signals the pilot to release the weapon. 500 meters east, the aircraft carrier USS Abraham Lincoln is making 30 knots into a headwind. The massive carrier cuts through the water as waves break against its bow. The wind rushing over the deck is exactly what the flight crews want, helping aircraft lift off more efficiently. On the flight deck, crews in brightly colored vests move quickly and confidently across the surface, guiding jets into position. The loud roar of engines fills the air as one fighter prepares to launch. An F-15E Super Hornet from VFA 41 Black Aces sits locked onto Catapult 1, its engines already screaming at full power. The pilot gives the final signal. In an instant, the catapult fires. The aircraft is violently pulled forward down the deck. In less than 3 seconds, the jet goes from 0 to 165 miles per hour. The nose lifts, and the Super Hornet leaps off the carrier, climbing into the sky above the Gulf of Oman. The Black Aces squadron has a specific destination in mind. Their mission tonight is to strike Chabahar, Iran's only deepwater port located on the Gulf of Oman. The port has strategic value because it allows Iran access to the open ocean without passing through the narrow Strait of Hormuz. The strike has already been carefully prepared. 20 minutes earlier, Tomahawk cruise missiles hit the area first. The missiles targeted the port's main command post along with large fuel storage facilities. Those explosions caused confusion and disrupted communications across the base. Now the fighter aircraft arrive to strike the remaining military infrastructure. The lead Super Hornet lines up its attack path as it approaches the coastline. The pilot selects a GBU-31 JDAM, a heavy 2,000-pound bomb guided by GPS coordinates. The target is the submarine pier inside the port. The pilot rolls the aircraft into a steady dive, the targeting computer locking onto the exact location of the pier. At the correct release point, the bomb drops cleanly away from the aircraft. The JDAM falls quickly toward the target below. Its guidance kit constantly adjusts the bomb's fins, keeping it on the programmed course. Seconds later, the weapon slams directly into the submarine pier. The explosion sends concrete, steel, and debris flying outward into the harbor water. 30 seconds later, another jet arrives. The second aircraft belongs to VFA 14 Top Hatters, flying as the wingman to the first strike. This pilot carries another 2,000-pound bomb and aims for a different target inside the same port complex. The dry dock facility, used for repairing ships and submarines, a third pair of aircraft moves toward the final target in the area. These pilots have been assigned to eliminate a coastal anti-ship missile battery positioned on a bluff overlooking the sea. The battery operates C-802 missiles, capable of threatening ships traveling through the Gulf of Oman. Destroying it removes a major threat to naval forces in the region. Instead of large bombs, the pilots release 2 GBU-39 small-diameter bombs. These weapons are much smaller, but extremely precise. Each bomb unfolds small wings and begins gliding toward the target location. They travel quietly and accurately, guided by satellite coordinates. Within moments, the bombs reach the bluff where the missile battery is positioned. The explosions tear through the equipment and launch systems. When the smoke clears, the anti-ship missile battery has effectively been wiped out. The radar equipment, launch rails, and support vehicles are destroyed. By this point, the larger strike campaign is spreading across the region. Coordinated attacks involving Tomahawk missiles, followed by fighter aircraft, have now hit several major Iranian naval facilities. The ports at Asaluya, Chabahar, and Bandar Abbas have all been targeted in rapid succession. Each location experienced the same pattern: cruise missiles striking first to weaken defenses, followed by aircraft delivering precision bombs against the remaining targets. While those attacks are underway, electronic warfare aircraft are performing another critical task. An EA-18G Growler from the Abraham Lincoln's Air Wing monitors radio frequencies and radar emissions across the region. The Growler's powerful sensors suddenly detect a signal coming from the mountains near Kermanshah. The signal belongs to an SA-65 Mobile Phased Array radar system. This air defense radar has a range of roughly 150 kilometers and is capable of guiding surface-to-air missiles toward incoming aircraft. The Iranian battery commander activates the radar fully, switching to fire control mode and broadcasting a continuous tracking signal as he searches for targets. The moment that radar switches to full power, the Growler reacts. Its ALQ-249 next-generation jamming system begins transmitting powerful electronic interference directly on the radar's tracking frequency. The jamming signal floods the radar receiver with noise, making it extremely difficult for the system to lock onto aircraft. At the same time, another aircraft already has detailed information about the radar site. An Israeli F-35I fighter has been quietly observing the radar emissions for the past 90 minutes. The stealth aircraft recorded the exact location of the system and now sends those coordinates through the Link 16 data network to friendly aircraft nearby. The pilot selects an AGM-88 anti-radiation missile designed specifically to destroy enemy radar systems. The missile drops from the aircraft's pylon and immediately ignites its rocket motor. It accelerates rapidly, approaching nearly 3 times the speed of sound. The missile's guidance system combines several different technologies. It already knows the radar's coordinates through GPS and inertial navigation, while its millimeter wave seeker helps it locate the radar precisely during the final seconds of flight. From the moment the radar signal was detected to the moment the missile strikes the site, less than 90 seconds pass. Elsewhere in the sky, 12 F-22 Raptor stealth fighters push eastward into Iranian airspace. These aircraft are among the most advanced fighters ever built. The lead Raptor activates its APG-77 radar system. The radar can detect objects the size of a golf ball from more than 125 miles away. At the same time, the aircraft itself remains extremely difficult to detect. Its radar signature is so small that it appears on enemy sensors roughly the size of a marble. This combination allows the F-22 to observe targets while remaining nearly invisible. Another important system on the aircraft is the AN/ALR-94 electronic surveillance suite. More than 30 small antennas are built into different parts of the wings, fuselage, and tail. These sensors quietly listen to every radio and radar signal coming from the ground below. During the ongoing battle, several air defense units attempt to relocate to avoid being destroyed. One mobile surface-to-air missile battery moves to a new position during the morning chaos. But when its search radar activates again, the F-22 sensors detect the signal instantly. The aircraft calculates the new location and records the coordinates. At the same time, another signal catches the attention of the pilots. An Iranian Revolutionary Guard command post is communicating using a radio frequency that the operators believe is secure. However, the F-22 sensors capture the signal and identify its source. The coordinates of the command post are logged and immediately sent through Link 16 to an F-15E Strike Eagle flying about 60 miles behind the stealth fighters. Meanwhile, Israeli strike aircraft continue searching for another type of target. 30 F-15 Ra'am fighters carrying Rafael Spice glide bombs and Delilah cruise missiles spread out across 3 different provinces. Their mission is to locate transporter erector launchers, also known as TELs. These heavy trucks are used to carry, raise, and launch ballistic missiles. Israeli drone footage soon captures one of these launch vehicles in a narrow valley. The vehicle is already preparing to launch a missile. The large missile is standing upright on the launcher, fully raised into its firing position. Several ground crew members stand nearby, connecting the final fuel lines and equipment needed before launch. Inside the cockpit of a nearby F-15, the weapons officer studies the live drone video feed. He waits carefully, watching the crew finish their preparations. The goal is to strike when both the launcher and the missile are most vulnerable. When the ground crew finally step back from the fuel connection point, the officer gives the command to release the weapon. A Raphael Spice glide bomb drops from the aircraft and extends its wings as it begins its descent. The bomb's guidance system combines GPS navigation with electro-optical targeting. It follows the valley toward the launch vehicle, aiming for the base of the launcher. The chosen impact angle allows the explosion to cover both the truck and the missile at the same time. The bomb strikes precisely at the junction where the launcher rail connects to the truck chassis. The warhead detonates instantly. The Shahab-3 missile mounted on the launcher suffers catastrophic damage as its fuel tank ruptures. Nearly 3 tons of liquid propellant ignite in a massive secondary fireball that fills the narrow valley. Not long afterward, another wave of Israeli aircraft enters Iranian airspace. 30 additional fighter jets spread across the regions of Isfahan, Bushehr, Avaz, and surrounding areas. Their targets include ballistic missile storage warehouses, production facilities for air defense systems, headquarters used by drone units, and large depots storing Shahed drones. Inside several warehouse complexes, rows of Shahed 136 one-way attack drones are already assembled. Many are fueled, armed, and programmed for launch. They sit stacked in racks waiting to be deployed. Precision weapons begin striking those facilities one after another. JDAM bombs and small-diameter bombs hit warehouse after warehouse across 3 different provinces. The explosions tear through buildings filled with equipment and drones. By the time the attacks finish, approximately 950 drones have been destroyed. At the same time, United States forces conduct their own strikes deeper inside Iran. Their targets focus on command and control infrastructure used by the Iranian Revolutionary Guard. Underground bunkers, communication relay stations, and major fiber optic network nodes are all attacked in coordinated strikes. The damage to those communication systems has immediate effects across the country. As key network connections fail, internet traffic throughout Iran collapses rapidly. Within a short period of time, the nation's internet activity falls dramatically until it reaches only 4% of its normal capacity. A 2,000-pound GBU-31 bomb drops from the aircraft's centerline station. As it falls, the JDAM guidance kit activates, and 4 metal grid fins deploy from the tail. The bomb begins adjusting its flight path several times each second as it falls toward the target. For roughly 30 seconds, the weapon drops silently through the air. Then it strikes the concrete arch of the shelter with enormous force. The hardened casing punches straight through the roof before detonating inside the enclosed structure. The explosion fills the confined space instantly. The pressure wave has nowhere to escape. The blast pushes outward with tremendous force, shattering the walls of the shelter and throwing debris in every direction. The heavy roof collapses downward, crushing the boats that had been protected beneath it.